and the other units will be there for your MCQs. Okay. So descriptive questions, you all can note down the question chapter numbers. You ready, all of you?
Yes, ma'am.
Okay. So descriptive questions will be there from chapter 1. Okay.
Yeah.
Then chapter 2, chapter 3, and chapter 11. Okay. So these are the units that you will be having the descriptive questions. Okay. You want me to repeat again? So chapter 1, 2, 3 and 11, these are the units that are selected for descriptive questions. Okay.
One full chapter, ma'am.
No. See, questions you will be getting 6 questions, right?
Okay.
6 questions you will be getting. These are the 4 units from which for sure 4 questions will be there. Right? The other 2 questions will be selected randomly from any of the other units which are there for your MCQs, right? From those units, the other 2 questions will be selected.
Do you have any model paper kind of thing where you can show us, ma'am?
No model question paper is available for this. Okay. You will be getting 6 questions, out of which you will be answering 4 questions. Okay. So these 4 units from which you will be getting questions for sure, those units I have told. The other 2 questions will be randomly selected from the rest of the units, for which anyways, because you're preparing for MCQs, you will be for sure knowing what are the answers, right? So that will not be a problem for your.
You mean MCQ for all units, 1 to 15. You mean?
No. The rest of the units which are left, only from that you will get MCQs. Clear, all of you? 1, 2, 3 and 11 for descriptive. The rest of the units you will be getting the MCQs. But other 2 questions can be selected from any of these units. Okay. So I'll just tell you what are the some of the important topics, like how you will be preparing for the descriptive part. Okay, I'm not telling you the exact thing that only these things will come. I'm just telling you what are the possibilities and how the question can appear. All right. So just so the first unit we have got, right? So in the first unit, that is basic structure of computers and instruction set. So under this unit, we have got the different types of computers, right? So there, you can go through these different types of computers that are there, the different, okay, and functional units are there, okay, go through those also. And then you have got this performance, okay, the basic performance equation is there, and the representation of your number, that is the 3 ways of representing any binary numbers of sign numbers, right? That is your sign and magnitude, one's complement and two's complement. This is very important, this one. And the last one, that last unit you have got, no, that big Indian and little Indian, that is also very important. So you can get so these are some topics which are important from this unit 1. Okay, so just go through these things. It's not that you're not going to go through other things, but give little more importance on these kind of topics. Now we have got the unit 2, which is machine instructions and programs. Here, see the overall unit here in this, no, the addressing modes. The center of attraction of this unit itself is addressing modes. Very, very important topic. So go through all the addressing modes, okay, with examples. You should be knowing it with examples. And mm, assembler directives. The other very important thing is your program. There are three methods of IO operating, right? Program controlled IO, interrupt IO, and your DMA technique. These are the three important techniques in this. So these three important techniques, each one of them you should be knowing with explanation. Program, interrupt, and DMA. All right. Addressing modes are there. The different IO modes, that is program control, interrupt, and DMA. That one, and your assembly directives. These are all certain topics that are quite very important from these units. So when, if you, for example, if it is, say for example, if any question arises from the topic of program control IO, so what you will be explaining, you will tell what is program control IO. Then you will put up the diagram. Okay, see if you're talking, explaining something, and if there are any diagrams in that, if when you're putting up the diagram and explaining, you will fetch more marks for it. Okay, then after putting the diagram, you in this now, for example, in programmed IO, you have got data in, data out as the registers. So explain all that, whatever is there. Okay. And one more thing that I wanted to tell is attempt the questions. Whatever you know, you write the answer. Okay. If the question is asked, whatever you know, you just write something for it. Don't just leave the question like that. But let it be something connected to that particular unit. Okay. And then stacks and queues also you can just go through. Okay. These are all some important units, topics of these from the second unit. And then we have got third unit. So your IO input output organization. So I'll tell you that prepare properly for this unit because it requires little bit of preparation because you know the synchronous, asynchronous DRAM techniques in this. So one day before the exam you cannot prepare at all. So just uh, spend some time in preparing this third unit. So in this,
Apart from output organization, what did you say, ma'am?
I didn't start it in this unit. I'm just
Okay.
Hmm. So accessing IO devices. So how accessing IO devices? Those three techniques that you will be studying in the previous unit, that is programmed IO and your interrupt driven IO, no, that is again repeated here in this unit. So that thing you just go through. The programmed IO and interrupt driven IO. And then there are two methods in this unit. One is uh, so DMA you will be preparing from this unit. That unit has got only programmed controlled IO. Okay. In this unit you will have interrupt. In that unit also some part of interrupt driven IO is there. But interrupt driven IO and DMA in detail you will find in this unit. Okay. So see accordingly and prepare. If DMA is asked, you have to put the diagrams, explain all the registers. Wherever diagrams are necessary, don't forget to put the diagrams. The other very important unit topic here is your synchronous and asynchronous bus transfers. Okay. So you have got the synchronous and asynchronous protocols here. That also you can prepare. Very important topic again. The actual unit itself is about the synchronous and asynchronous. So give more importance to these two units. Okay, these two units from this unit, these two topics, synchronous bus and asynchronous bus, then interrupt driven IO, DMA, then the different ways of accessing the IO devices. So these things you will give little more importance from this unit. And then we have got the 11th unit. Okay, 11th unit, as you all know, the unit is very small unit, and um, so there you have got lot of definitions. So you can only prepare for such definitions. I cannot tell you what is important and what is not important because the entire unit itself is very small. I I suggest you to go through all the definition, give more importance to laws like Amdahl's law is there, okay, and then we discussed about the paragraph tool, right? So give more importance to the paragraph tool, Amdahl's law, okay, and the other definitions that are there, speed up and your performance, scalability. So all these definitions, you just prepare for all these definitions. Okay, this unit is more about definitions and Amdahl's law, Gustafson's law is there, and your paragraph tool is there, right? So give importance to all these, prepare for all these and come. So these are the units from which you will be getting the descriptive questions. So the rest of the questions will be from other units. Okay. Someone says, ma'am, please repeat topics of second unit. Second unit, I told you, no, the programmed IO is there, then your IO communication, your stacks, subroutines. Go through all that. Addressing modes. Addressing mode is very important. Go through addressing modes. Okay. That unit itself starts with the very important topics of addressing modes. So first prepare addressing modes with examples, then start preparing the other thing. Addressing modes and your programmed IO, then interrupt driven IO is there. Ma'am, can you repeat unit number once again? Unit number is 1, 2, 3 and 11. These are the units from which you will for sure get the descriptive questions. Other units also you will get, okay, but that will be randomly. All okay, all of you? So what we will do is we will go through some of the MCQs, okay, because you have, I think you have attempted 3 of your CAs, right? So for the final exam also prepare for all those MCQs, okay, and go through all that assessments, whatever you have given, prepare for that also. Apart from that, we'll discuss some of them now, okay? So just listen and try to answer some of them. These questions are unit numbers you have taken down, right? 1, 2, 3 and 11. Topics also important topics, whichever I have told it is important, give more importance to that. Rest also you have to come prepared. I'm not telling you that only these topics will come, the questions will come from only these topics. No, units I have told you, but some more importance you will be giving on these topics, but you're going to prepare these units properly and come. All right. Topics I have already told, I'm not going to repeat again. Okay, let us not waste time and start doing MCQs. We'll see if at last time is there. I'll repeat once again. Okay. Okay. So listen to the question. Every time on starting your computer, you observe a certain chain of command screens, mostly containing computer operation information, until you reach an interface that can be controlled by you using a keyboard and mouse. Identify from the following which regulates the interface window. Okay, the options are command prompt, RAM, bootstrap loader, and hard disk. What could be the answer? Don't type the answer. I'm not on the screen. Tell the answer. Fast. If you tell me fast, then we can proceed to the second question.
Option C.
Bootstrap loader. Bootstrap.
It's good.
Bootstrap loader.
Okay. Now, see the next question. Bootstrap loader information is stored in which of the following? RAM, hard disk, ROM, command prompt.
ROM.
Come again?
Command prompt.
Oh, it is in the ROM.
ROM.
Last unit we have discussed, right? The basic requirement whenever we are loading the ROM is a disk. ROM in the ROM itself, it requires no initialization, right? That's why to initialize the operating system, the Bootstrap loader program will be there in this read-only memory. Okay, so this Bootstrap loader information comes in ROM because it requires no initialization. So the answer is ROM. Then, um, hmm. A RAM chip having a capacity of 64 bytes will have how many address lines? I'll not give you the option, it should tell me the answer like that. A RAM chip having a capacity of 64 bytes will have how many address lines? Quickly. It is 6. Next. Which of the following define best for memory address map? Which of the following defines the best for memory address map? The options are addressing of memory can establish by means of a table that specifies the memory address assigned to each chip. Okay, so here what are we doing? The question is about it is about the memory address map. So which of these definitions will hold good for memory address map, that you have to tell. Okay, so what actually is memory address map, you have to tell. So the first option says it means addressing of memory can establish by means of a table that specifies the memory address assigned to each chip. Okay, this is the first option. The second one is addressing of memory can establish by means of index that specifies the memory address assigned to each chip. Addressing of memory can establish by means of a table that specifies the memory address assigned to each secondary storage device. The fourth option is addressing of memory can establish by means of a table that specifies the memory address assigned on only RAM. Okay, I'll tell you the answer for this because unless you read this, you will not get if I'm reading. Okay, the answer for this is addressing of memory can establish by means of a table that specifies the memory address assigned to each chip. Okay, this is the answer for this. The first option that I read out.
Once again, ma'am, this one, what you said, establishing?
Addressing of memory can
Yeah.
establish by means of a table that specifies the memory address assigned to each chip. This is the meaning of memory address map. Okay. See the next question. Which of the following represents the number of characters transferred per second? I'll repeat the question. Which of the following represents the number of characters transferred per second? Access time, capacity, transfer rate, cost.
Transfer rate.
So, transfer rate is the right answer.
What is that?
Transfer rate.
Yeah, that is what I said. Yeah.
Okay. Then, next question. Identify from the following which is a disadvantage of auxiliary memory. So, what is auxiliary memory?
Secondary
The
memory.
secondary memory.
Secondary memory is the auxiliary memory. No, I cannot share the screen. Okay, that's why I have kept the camera off. I'm just reading it out. Okay, just listen. So, auxiliary memory is nothing but your secondary memory. Which identify from the following which is a disadvantage of auxiliary memory. Low capacity, high cost, slow access time, complex to use.
Slow access time. Slow access time.
Very easy question. Okay. Then, which of the following is the disadvantage of dynamic RAM over static RAM? You can tell it as it without any options, I think. The main disadvantage. Come on.
Question once again, ma'am.
Which of the following?
Cost and speed.
Once again. Which of the following is the disadvantage of dynamic RAM, DRAM, okay, over SRAM? Come on, tell me the main disadvantage that we have discussed twice in the sessions. Dynamic RAM, DRAM and SRAM. SRAM is nothing but cache. DRAM is nothing but your main memory.
Faster. Speed. Ma'am, it losses data frequently. Dynamic RAM.
So,
The options.
the options given are high power consumption, variable speed, need to refresh the capacitor charge.
Yeah. Need to refresh.
Intensity. So, need to refresh is the answer. Okay. Fine. Then, which of the following are the fastest means of memory access for CPU? Which of the yeah?
RAM.
First, listen to the options. Which of are the fastest means of memory access for CPU? Okay.
Memory.
It is registers, cache, main memory, and virtual memory.
Cache.
Cache.
I'm now feeling that why you
This.
Virtual.
who said virtual? No, I want to know who said virtual now. For sure, you might have not attended the class of virtual memory. That's why you are telling virtual memory. The answer is registers. Registers are something which are already there with the processor, right? So the faster access is registers. After register, it is cache, then it is RAM, then secondary storage. Okay. There is no concept of virtual at all here in the memory now. So the answer is registers. Okay. Which of the following are the fastest memory access for CPU means it is registers, not virtual memory. Now, next one. Identify the appropriate abbreviation of SDRAM. Come on, tell me what is SDRAM?
Synchronous dynamic RAM.
Synchronous dynamic RAM. Correct. So here I have just given synchronous DRAM, static DRAM and all that. Okay. Synchronous DRAM is the answer. Good. Now, identify the block transfer capability of DRAM. Identify the block transfer. What do you call the block transfer capability of a DRAM? Okay, I'll tell you the options. Okay, the options are burst mode, block mode, fast page mode, fast frame mode. Burst mode, block mode, fast page.
Block mode.
Fast page mode.
The answer is fast page mode. Okay. Fast page mode, just go through it. What is fast page mode? Block transfer method of DRAM is fast page mode. Now see. Identify the correct statement from the following. First statement is CPU and cache memory has a bidirectional connection. Okay. CPU and cache memory has a bidirectional connection. Second statement is cache memory and main memory has a unidirectional connection. So which one is true and which one is false in this?
Unidirectional.
Unidirectional is what? True.
Cache memory and main memory have unidirectional connection.
Cache memory and main memory.
Yes.
Okay. The second one, first one is correct. That is CPU and cache memory has got a bidirectional connection is correct. Okay. So first
Oh
one,
yes, sorry. Yes, bidirectional. I wanted to mean bidirectional. That means both directions.
CPU and cache memory is bidirectional. So statement 1 is true. But cache memory and main memory is unidirectional. So statement 2 is false. Cache
False. Yes.
is not uni.
Uni means one directional. Yes.
It is
False.
bidirectional in nature. Okay. Then, which of the following parts of the addressing system can be common to both a block and a page? I'll repeat again. Which of the following parts of addressing system can be common to both a block and a page? So options are whether it is page number, line number, word number or key number.
Page number.
No. It is line number. Okay. Next.
Is
Answer.
common, madam, common for what you said actually?
Common to both block and page.
Block and page.
The answer is line number. Okay. Which of the following memory improves the speed of execution of a program? Which of the following memory improves the speed of execution of a program? Primary, cache, secondary, virtual.
Cache memory.
Cache memory. Cache memory. Now see the next question. In case of a miss, what do you call the extra time needed to bring the data into memory? In case of a miss, what do you call the extra time needed to bring the data into memory? Delay, propagation time, miss penalty, cache miss. Cache miss means if there is no data, you call it as cache miss, correct? So when a cache miss happens, then later the data has to be brought in. So what do you call that time as? That is the question. So the answer is miss penalty. Okay. Next. The method of mapping the consecutive memory blocks to consecutive cache block is called as. You have to answer without any options. Let's see. The method of mapping the consecutive memory blocks to consecutive cache blocks. The options are Set associative, direct and indirect.
Associative, Master.
Oh, no, it is direct. So whichever blocks are already defined, there only you will be putting the data, right? So consecutive memory blocks to consecutive cache blocks. You cannot simply randomly put here and there. Okay, so already it is fixed. There you call it as direct. While using the direct map technique in a 16-bit system, the higher order 5 bits are used for which of the following purpose? I'll repeat the question. While using the direct mapping technique in a 16-bit system, the higher order 5 bits are used for which of the following purpose? So what is it saying is, while we were discussing about this mapping techniques, we have divided the physical address into logical address. Okay, we have divided into parts, right? We have divided it into tag, line number. Okay, so that higher order 5 bits are referring to what? That is the question. So the options are tag, block, word, and ID.
Tag.
So tag is the correct answer. So what is the full form of LRU?
List recently used. List recently used.
Least recently used. Identify from the following which is not a cache mapping technique. Direct mapping, associative, set associative, memory mapping.
Memory mapping.
Memory mapping is the answer. Identify from the following which suits the spatial locality of reference. Spatial locality, you remember? Spatial locality and temporal locality are the two principles of locality, right? So now from the options given, you have to identify which one is spatial locality. Options are recently executed instruction is executed again next. This is the first one. Second one, recently executed instruction won't be executed again. Third one, the instruction executed will be executed at a later time. Fourth one, the instruction is in close proximity of the instruction executed will be executed in future.
Fourth one.
Fourth one is the right answer. Okay. The instruction in close proximity of the instruction executed will be executed in future. Which of the following gate helps to introduce a delay in normal course of design circuit logic, not changing the course of design circuit logic? That means, I'll tell you what is this. Okay, the options given are AND gate, buffer gate, OR gate, and NOT gate. Okay, the answer here is buffer gate. So what is this question is? This is one of the circuit. Okay, buffer is one of the circuit. It is a logic. It's a gate wherein if you give the input as 1, the output will also be 1. If you give the input as 0, the output will be 0. So whatever input you will give, the same will be the output. Okay. So that is the question here. Which of the following gate helps to introduce a delay in the normal circuit? Okay. Not changing the course of the design circuit logic. That means it won't change your output. So the answer is a buffer gate. Now, so what will be the Boolean expression for that? That is the next question. What is the Boolean expression for your buffer gate? So Boolean expression, because when you are giving the same input, the output will also be the same, right? So the Boolean expression will be the expression options given here are y is equal to x plus 1, y is x minus 1, y is equal to x, and y is equal to x minus 2. What do you think might be the Boolean expression for this? X plus 1, x minus 1, x or x minus 2? X. So y is equal to x is the correct answer, because whatever you are passing in, that is same thing as passed out. See the next question. Which of the following is an example of a basic gate? Which of the following is an example of a basic gate? Buffer, XNOR, XOR, OR.
Or gate.
No, it's not OR. It is for. I am not including OR here. Buffer, XNOR, XOR, and for.
Or
For is not any gate, and there is just an option. Buffer is not. Okay. Remember, example of the basic gate. If OR is not given, then you will go. You will write as buffer.
very confusing. Buffer is this. Basic gate I did not hear earlier.
Okay.
Buffer.
And that generally the classification is only 3. Okay. But buffer is a simpler gate, very basic kind of gate.
Okay.
Which of the following logic gates provide the output as 0 when the inputs are same? Which of the following logic gates provides output as 0 when the inputs are same? Inputs are same in 0, 0, 1, 1. When 0, 0 is the input, the output is 0. When 0, 1, 1 is the input, output is 0. Which gate gives this kind of answer? XNOR, XOR, NOR, and NAND.
XOR.
XOR gives this kind of output. Okay. Sign magnitude representation is used for which of the following? Positive number, negative number, infinity, or 0?
Positive.
Sign magnitude representation. Negative, right?
Or negative.
NOR gate is the complement of which of the following? AND, OR, NAND, NOT.
Or
It is OR gate.
OR.
Which of the following can be used in the construction of SR flip-flops? Which of the following can be used in the construction of SR flip-flops? Options are AND or OR, XOR or XNOR, NOR or NAND, AND or NOR. AND or NOR. Okay, the last one is. The answer is NOR and NAND gates. By using NOR and NAND gates, we can make SR flip-flops. So what is the expression for a NAND gate? Can anybody tell me? Expression of a NAND gate.
X dot
No,
y
no,
is equal
no.
to x plus b. Sorry, x plus y.
not
No.
not an and.
NAND gate.
Not an and.
You have to tell me the expression like a dot b, x dot y, a complement, x complement, y complement, like that. Okay, here I'll tell you the options. So the options are a dot b, a complement b plus a b complement, or a dot b the whole complement, or a plus b the whole complement.
A dot b the whole complement. Whole complement.
Dot b the whole complement. Which of the following decides the manner in which the control signals will be generated in a control unit designed on the principle of microprogrammed control unit? Microprogrammed control. Okay. Which of the following decides the manner in which The control signals will be generated in the control unit designed on the principle of microprogram control. So whether the answer is logic gates, data bus, memory or decoders.
Microprogram.
Yeah, in microprogram control unit, what decides? The answer is memory. Memory is the answer. I repeat the question. Which of the following decides the manner in which control signals will be generated in a control unit, which is designed on the principle of microprogram? So in microprogram, everything is software based, right? You have written the code and you have put it into a memory, which is known as what? What do you call that memory as? Control store, right? So here your answer is memory. If it is hardwired control unit, so there it's basically you are going to tell that it is the logic gates that you are using. Here, if it is microprogrammed, it is memory. In hardwired control unit, because everything is based on hardware, the answer would be logic gates. Now, which of the following commands can stop a running instruction cycle? This also comes under the same unit of your logic microprogram and your hardwired control unit and microprogram control unit. In the diagram, it is given. Okay. So, which of the following commands can stop a running instruction cycle? So, there we have used these instructions: STP, INR, HLT, or SKI. Okay. It is HLT, halt signal. It will stop the running instruction. So the answer is what? HLT. Mute Prasanta Kumar. There's noise coming from your side. IO device, input and output devices can take data or put data in which of the following? Accumulator, temporary register, address register, or logic gates. Accumulator is the answer. In a control unit, sequential counter provides information to which of the following? So in hardware control unit, the circuit diagram, the sequential counter is there. Okay, that sequential counter is providing information to which of the following? Whether it is 3 to 8 decoder, 4 to 16 decoder, or control gates, or whether it is 3 to 18 decoder. So, yeah. Mute. So 4 to 16 decoder is the answer because we use the 4 to 16 decoder there. Okay, so that is the answer. See this? The registers ALU and the interconnecting path within a processor are collectively called as what? Hmm? This is the topic that we discussed in our single bus and multi-bus organization. You will tell the name without the options. The registers ALU and the interconnecting path within a processor are collectively called as what? See the options: control path, data path, flow path, direct path.
Data path.
Data path is the answer. Identify the operation performed by end instruction, END, end instruction. Okay. It ends the generation of the signal. It ends the complete generation process. It starts a new instruction fetch cycle and resets the counter. It is used to shift the control to the processor. What is
It starts, as you said.
Yeah. The third one, it starts a new instruction fetch cycle.
Exactly.
Sets the counter. Okay, that is answer. Which type of control unit generates control signals by using combinational circuits? Microprogram, hardwired, logic, or software?
Hardware.
It is hardwired. Which signal enables the processor to wait for a memory operation to complete? Tell me. Which signal?
Can you repeat, ma'am?
Okay, I'll repeat. Which signal enables the processor to wait for a memory operation to complete?
Ma'am.
FFC, TLB, WMFC, ALB.
WMFC. WMFC.
The answer. Identify the register which is connected to the processor bus is a single way transfer capable. Okay, this is one of the register which is connected to the processor bus, and you can only perform a single transfer. Okay, PC, IR, temp, and Z. You just recollect the
Z. Z register.
register. Okay, you have to recollect the memory single bus memory or organization, single bus organization. So there we have made use of Z register. Okay, so Z is the answer. See, listen to this question. Point 1 is addition of mantissa. Point 2 mantissa alignment. Point 3 exponent comparison. Point 4 is result normalization. Identify the sequence of steps to be followed in order to add two floating point numbers. So what is the sequence that you will be following to do the addition of any two floating point numbers? Whether it is addition of mantissa alignment, exponent comparison, or result normalization. Which one is the first one? First is you will compare the exponent, right? So third one, exponent comparison is the first step that you will be doing. Then after comparing, if the when you see that the powers are, if they are not aligned, then what you will do? You will do the mantissa alignment. Okay. Then what you will do? Once the mantissa is aligned, you will add the mantissa. After that, last is you will do the normalization for the result. So 3214 is the answer. Then, which of the following is the first step when branch instruction or interrupt takes place? Which of the following is the first step when branch instruction or interrupt take place? Options are fetch operand, empty the pipeline, update PC, depends on other factors. Update PC is the right answer. See this. When the fetch segment and execution segment of a pipeline access the memory at the same time, this can be referred as what? Yes? You all know this. What is it called as? Fetch segment and execution segment of a pipeline is accessing the memory at the same time. What do you call this as? See the options: resource conflict, dependencies, branching conflict, branching dependencies. How it is different? Me, it is resource conflict because there are two segments which are trying to access the same resource at the same time. So it is called as resource conflict. Fetch segment is also accessing the memory. Execution segment is also accessing the same memory at the same time. Okay, so it is called as resource conflict. So the answer is resource conflict. Which of the following is not a feature of a risk pipeline? Less memory access, more addressing modes, fixed instruction format, efficient pipelining. Hmm? Which one?
Lord.
No, not a feature of risk pipeline it is. See, risk has architecture has got a very efficient pipelining. Okay. Risk architecture has got a very good pipelining. So the answer efficient pipelining is wrong. More number of addressing mode is the wrong answer. More addressing modes is the one here because in risk architecture we have got very few addressing modes, right? And the addressing modes are also simpler when compared to your complex instruction set. So the answer here is more addressing modes. Conflicts based on a delayed branching in a risk pipeline are solved by which of the following? Okay, so the answer, options are compiler, memory, addressing mode, and accumulator. So those kind of dependencies are solved by your compiler in these architectures. So the answer here is compiler. Which of the following is used to hold the results of intermediate stages in pipelining? Caches, buffers, RAM, memory. Buffer is the correct answer. Identify from the following which increases the pipelining of CPU instructions. Size, throughput, cycle rate, time.
Cycle rate.
Throughput. Throughput is the answer. How many segments will be formed to perform the operation x into y minus z using pipelining technique? See the operations x into y minus z. Okay. So the options are 2, 1, 3, and 4. What is the answer? How many segments will be formed to perform the operation x into y minus z? How many operations are we performing here? X into y. One is multiplication, the other one is minus z. Other one is subtraction. So two segments will be formed. Okay. What is the alternate name for pipelining process? Other name for pipelining process.
Options.
That is parallel.
I thought you all will tell it like that only. Okay.
Assembly.
Parallel.
Assembly line.
Assembly line is the answer. Superscalar operations, assembly line, volume and vector processor. Assembly line is the correct answer. Which of the following leads to concurrency? Parallelism, serialization, instruction fetching, distributed processing.
Parallelism.
Right. Okay. Which of the following is an example of fourth generation computer? IBM 701, UniVac LARC, VAX 9000, IBM 360. So VAX 9000 is the answer for this fourth generation computer. You can write down somewhere.
Wax.
VAX 9000, fourth generation of computer. What is the abbreviation of MIPS? MIPS. Yes?
Millions per instruction. Millions per instruction
Millions,
or instruction
millions of instructions per second.
per second.
Which among these is not a PRAM variant? Okay. EREW, ERPW, ERCW, CRCW. What is
EREW.
ER?
EW.
ER?
EREW.
No, dear. EREW is not the correct one. EREW is exclusive read, exclusive write. So that is there. Exclusive read, exclusive write is there. So ERPW is wrong because this is something which is not there. Then ERC is exclusively read, concurrently write. CR is concurrently read and concurrently write. Okay, so ERPW is the wrong answer. I mean, that is the right answer, which is not one of the PRAM variant. Okay. What is the abbreviation of ULSI? VLSI, you know. What is ULSI?
Ultra large.
Integration. Scale integration.
What is VLSI?
Ultra large speed instruction.
Very large.
Very large.
Very large what?
Scale
Scale
integration.
instruction.
Integration.
Integration, sorry.
VLSI is very large scale integration. ULSI is ultra large scale integration. Okay. Which generation of computers started using vacuum tubes as the basic components?
First generation.
First generation.
First generation is the correct answer. Identify from the following which is a zero memory access overhead. PRAM models, VLSI models, RAM models, and ROM models. Answer is PRAM models. Okay, these are zero memory access overhead. PRAM models. These are the models which are only theoretically made. These are not something which are implemented. Okay.
You said PRAM model?
Yeah, PRAM.
Zero?
Zero memory access. Identify from the following which is